Alright, welcome back to day 40 of LeetCode grind. Solve or go home. 30 minutes solve or go home. Okay. Range sum query 2D immutable. Okay, given a 2D matrix, handle multiple queries of the following type. Calculate the sum of the elements of the matrix inside the rectangle defined by its upper left hand corner, row 1, column 1, and lower. Okay. So, alright, so this is a design question. You just want to sum the region that they pass you. Do they pass you a region? Yeah, they pass you row, okay, row col, and row 2 col. Okay, so yeah, so starting and ending. Ooh, okay. How's this brute force? Well, no, I mean, like, how is brute force too slow? So they give you a region, right? Oh, it's because if they give you the full region, that's n squared. But is n squared too slow?
They start from anywhere. Like they can start from any upper left corner and then any lower right corner.
Sure, but I'm saying worst case scenario is n squared, right? Is that too slow?
No. But if you okay, so it's n squared for each call, and then there's like thousands of calls.
Oh, but then thousands of calls of n squared is still n squared, isn't it? Same order?
No. Okay, so instead of having to pre-compute, instead of having to calculate everything from scratch every time.
Yeah. Then you yes, you can store with DP basically, right? So every time you do a calculation, you can store the sum of that, and then if you expand it outward, like the next sum includes that range, then you don't have to sum the stuff outside of it. But okay, so basically, given like the row column of starting and row 2 column 2, right? You can sum it first, and then you can store that sum. So next time they call like a, I don't know, like something that's almost something that encompasses that area, you can just pull that sum out and then just calculate the remainder. Does that work?
You write out what you need. I don't fully understand.
So let's say the example, right? If they did the 321015, so they wanted row 1 is what? Row 1 is 1, column 1 is 2, and then row 2 is 2, and column 2 is 4. So that means you want the area from 3 to 5, right? The sum from 3 to 5.
Right.
So if you sum this, you check to see if this current sum exists anywhere. If it doesn't, you sum it and then you store it. And then the next time you get a different query, you check to see if the range of what they're asking for lies within any of the ranges that you already calculated.
Sure, but it's not guaranteed that you'll have seen it before.
Yeah.
And so then you're still going to be having to do like computation on the fly, right?
Yes.
Okay. How about this? What if instead of a 2x2, or sorry, a 2D array, you have a 1D array? Let's just
Okay.
you have so we have an array and don't even care about them. Let's call it ABCD.
Okay.
Right. So let's just write that as an example. And my question to you is going to be, and this is only a small thing, right? So, if I were to ask you any subarray of this, would you get it to me in all of one lookup if you do some kind of pre-computation?
You said any subarray of this I need to get in O of 1 lookup? Okay. B
So if
sub.
I wanted just A or AB or ABC or BCD or CD or whatever, right?
Mm-hmm. Sure. Okay. Okay. Okay, so if you gave me a subarray, so like if it's A, B,
I
C, or
mean, I would give you like intervals. I would say like, can you give me the interval from one
yeah.
to three?
Okay, sure. So if it's
So
one,
and then you would be like, oh, it's BCD, right?
yeah, that's fine. So okay, if you give me 1 to 3, right? So if I do index 1, 3, that means I want BCD. So I check. So basically, what I want is to store. No, wait. Yeah, so if I store the interval sum.
Okay, that's a good idea. And what would that look like?
Okay, so on first pass, you don't have it, so then you have to calculate it. So after you calculate B plus C plus D, the interval 1 to 3 has the sum of A, B, C, D. I mean, B, C, D. So if you were to ask another interval of like, let's say 1, I can access this and then subtract out. Well, actually, no. If you ask for interval 1, you just return that by itself.
Right. And then what about interval 1, 2?
If it's 1, 2, then it's just the sum of. It's just 1, 3 minus 3.
Yeah. I mean, that's right. That's right. Okay. So, yeah, I'm not sure you're really going in the direction that I'm pushing for, but then I can just kind of I teach you the trick, right?
Okay.
So the trick here is that if you want all the numbers up from I guess interval 1 to interval sorry, let's say you have a left index and right index, right?
Uh huh.
And you have an array of running running sum.
Okay.
Okay, let's just start with that. Let's build an array of running totals. So what would that look like for ABC?
Sure. That's A, B, C, D, D. Well, it's like pluses, but yeah.
Sure. So if you want to get BCD, and you had to take which two of these numbers should you look at?
If I want BCD, I'm gonna be heading to Midtown.
Sure.
Now, if you want BCD, you just take the fourth one and subtract A out.
Exactly. So you see how if you have this array, now it's basically O of 1, basically O of 2, I guess, look up. Right? You look up the last guy in the interval, and then you subtract where the interval starts.
You look up the last guy.
No, so if your interval is 1, 3, then you look up the index 3.
Yeah.
Right?
And
Then you look up, it starts at the first element to start at index 1 instead of index 0, so you have to subtract anything to the left of the left index, right?
yes.
So let's say you wanted instead, CDE, right? What would you subtract?
CDE. So yeah, so that means you want to subtract A and B from the last one.
Right, exactly. So you're gonna take index 4 on the right side, and then you're subtracting index 1 from the on the left side, right?
Index 4 from the right side, subtracting index 1 from the left side. Oh, index 1 is A and B, yeah.
The the interval here would be 2, 4, right?
2, 4. 2, 4 is that correct? 2, 4 means you want
You start with 2 and then you end with 4, and so you want CD. And basically, 2, 4 will return CD.
Wait, does it? I thought. Wait, so interval. If you did 2, 4, right? That means. Okay, you want from the range from 2 to 4. Okay, so yeah. So you want CD, yes. But okay.
Right. You can look at the array and be like, oh, it's obviously CD.
Yes.
But if you look at the sums array,
yeah.
then which ones do you subtract?
So you want the 4th index, and you want to get rid of anything from the 2nd index.
You want to keep the 2nd index, but you want anything smaller than the 2nd index, or not anything smaller. One directly smaller. Right?
Wait, what does that mean?
Well, as you mentioned, CDE is ABCDE minus AB, right?
Yeah.
So what index is ABCDE?
ABCDE is index 4.
Right. What index is AB?
Index 1.
Okay. And how can you relate these to the interval?
So if it were that, it would be the totals array, and then you want to access the 4th one minus of the 2 minus 1.
Okay.
So if this were like x, y, then it'd just be y and x here.
Okay. So where does this break down?
What do you mean? Where does this break down? Like what edge cases?
What happens if x is 0?
I see. So if x is 0, yeah, you're out of bounds. So okay, so if you actually wanted 0 to 4. 0 to 4 means you want the whole thing, right? So just A, B, C, D, E. So in that case, oh, so if it's -1, just don't subtract anything. So if x is 0, just return the totals array of y. Else you gotta subtract 1 from it. Yeah.
So are you confident that you can get or that this method works? I guess.
It seems to work given this example. I could try a different.
If you don't trust this, then we cannot continue this way. Because right now, after you do this, you will have to do it in 2D.
Yeah, 2D is much harder. Okay, wait. So.
I mean, is it much harder? I mean, you can just have row sums for each row. Right?
That's true. You're right.
You're just doing the same thing, but multiple times, right?
Mm-hmm. Okay, so let's say you wanted 3, 4. So 3, 4 is just DE.
Mm-hmm.
So that means you're doing A, B, C, D, E minus index 3 minus 1, which is A, B, C. Yeah, so that's correct. Okay, that looks like it's good.
Right. And this is a common, I guess, trick, where if you have like some interval or some like sequence, getting an interval in that sequence is just a full sequence up to the last interval, or the right side of the interval, minus the full sequence up to the left side of the interval, right?
Okay. So when you say left side of interval, that's why you minus 1?
Yeah. Well, I mean, it depends. Well, sometimes it depends on whether the interval includes that element or not. If it doesn't, then you don't have to.
I see. Okay.
Anyway, so okay, what is your pseudocode strategy for doing this tweak?
Okay, yeah. So first off, we loop through the 2D matrix. Each row we build an array of the running totals for all of them, and then after given that, so I guess we would store it into a dictionary. A dictionary, each row has the. We don't.
Do you need a dictionary? You're gonna need all the rows anyway. So technically, you can have the same shape as.
Oh, we can just build another 2D array, basically.
Right. Exactly.
Okay, sure.
Like,
oh yeah, it'll be like the running total array. Okay. And then given that, when they ask for the row column, we just access that sum array and subtract out based on this example here. So we go to the totals array, we plug in the row that they give us, and the column.
Okay. Let's see if you understand this. What is y and x in this case?
In 2D form?
In 2D.
So in 2D form, you actually have x1, y1, and x2, y2. Yeah. Okay. So if they give you that, okay, that means you want. Okay. So given that. So in this example, there's 3.
And we can make the assumption that x2 greater than equals x1 and y2 greater than equals y1.
Yeah, we assume that, right? Okay, 3, 2, 1, 0, 1, 5. Okay, so if x1 is okay, let's see. So that should be. Which one was this? 3 starts was row 1, column 2, and then this one was row 2, column 4. So they give us that. They want the sum of this range. That means if I were to do the running total of this row right here, let me grab that full row actually. 5, 6, 3, 2, 1. And what's the other one? 1, 2, 0, 1, 5. Okay, so this transposed the running total rate. It's 5, 11, 11 plus 14. I should probably put commas. Yeah. 16 and 17. And this one is 1, 3, 3, 4, 9. 1, 3, 3, 4, 9. Yeah, that's good. Okay, so if they want the sum of this to this, then they want. Okay, so you do the first row, I believe. Okay, so if they want 1 to 2, then they do 1 to 2 means you do index 2, which is 14, minus
Whoa. What the hell 1 to 2?
1 comma 2.
What does 1 comma 2 mean?
X1, Y1.
Correct. So that's the index of the 3 in the 3 to 1.
Yes.
Okay. Okay, keep going. I might have interrupted you.
Okay, so wait. Is it 14 minus 1? Range 1. So that's 5. It's 9.
Well, does that match with what you expect?
Yeah, I'm trying to confirm now. Okay, if this was index 2, it says 3. So it's saying the sum of these is 9 plus 6, which is 15. But that does not seem right. Wait, is it? Wait. It's 3, 2, 1, 5, 1. So what is that? 7, 10, 12. It should be 12. So I got 15, but they want 12.
How did you get 15? And what are you actually expecting?
So I thought it.
And where's the 3, 2, 1 supposed to be? You do it 1D.
3, 2, 1?
Yeah,
3,
2, 1 to get.
Yeah, so this is 1D, right? So 5, 11.
Yeah. So what are you subtracting to get 3 to 1?
It's 3, 2. You're subtracting out these two, 5 and 6.
Okay. And what indices are those in the array?
0 and 1.
Back to line 8 and 9.
Yeah, so it would be 3, 2, 1 is sum of 3, 2, 1. Three, two, one is the CDE. So
Okay.
if you want that, yeah, so it would be index 4 is your last, and then you want to subtract out your AB, which would be index 1, yeah, 1 to 4. Wait, no. 2 to 4.
2 to 4. Okay.
And then this one, 0, 1, 5, is the same thing. It's also 2 to 4.
Right.
So
where are these numbers coming from?
x2, y2?
Not quite. The y2 is right.
But isn't x2 also 2?
And you happen to choose it. So, and maybe you want to do the 3 by 3 instead of the 2 by 2.
What do you mean by the 2
I don't
by?
think you're understanding what these numbers are.
Okay.
Okay. What is the 1 in the one. What is x? Where's x1 used?
X1 is used to figure out the row that it starts at.
Right. That's the 56321, right?
Yeah.
But what is x2 used for?
X2 is used for the ending row.
Right. So that's 12015, right?
Yeah.
I mean, if x2 and x1 are both used to pick up the rows, and what must be used to pick up the columns?
Y1 and Y2.
Exactly.
Okay. What does that mean? It doesn't mean anything.
So we know that y1 is smaller than y2.
Yes.
So do you not just use the same y1 comma y2 interval for every row that you encounter?
Do you not just use the same Y1, Y2? Wait, what does that mean? Say that again.
Okay. So let's go back up to the picture.
Okay.
And let's say instead of 321.015, we're also extending it to 017 as well. Okay, one level down. Okay.
Okay.
So the upper left corner would be I guess 1, 2.
Yeah.
And then the lower right corner would be I guess 3, 4, right?
Mm-hmm.
So what can you say about the intervals used in every row?
They're all 2 4s.
Right. Why is that?
Because the partition of that you're using is, that's how the interval is built. You want it from index 2 to index 4 for all of them.
Right. So the first part of the interval, like the x part gives you the row, and the y part gives you the left bound, right?
The x part gives you the row, and the y part gives you the what bound?
Left bound.
Left bound. What is a left bound? Oh yeah. It tells you your starting location. Yeah, sure.
Right. And then the second part of the I guess the 4 coordinates, right?
Mm-hmm.
That gives you the ending row.
Yeah.
And the ending right bound, right?
Yes.
So does it make sense how you would, I guess, extract each sub each section sum, I guess?
Okay, so wait. In that case, it was 1, 2, and 3, 4, right? 1, 2, and 3, 4. Yeah.
Yeah, I mean, you can reuse most of the work.
So basically, what you're saying is, to build each rows, it's just y1, y2.
I mean, am I saying that, or are you saying that?
Well, that's what you're saying. That's what you're saying, but also that's what the example is the pattern is showing.
Well, I wanted to pick something so that you wouldn't just be stuck on which one is X, which one is Y.
Mm-hmm. So basically, okay, so you given their example of x1, y1, and x2, y2, they give you that. So instead, we're using y1, y2 to build the intervals per row.
Does that make sense?
Well, the pattern dictates that.
No.
And they use x1, x2 as the loop of which ones you want to mess with. I mean, 2D arrays are slightly confusing, so I would be lying if I say I instantly understood why it does that.
Okay. So, what can you say about the shape of any interval that is in 2D?
Shape of any interval that's in 2D. What does that mean? What do you mean by shape of any interval in 2D?
But what is the shape of this green thing and the blue thing and the red thing? And any.
Oh, they're all rectangles?
Exactly. And for a rectangle, if the upper left corner is at a certain position, what can you say about the lower left corner?
It's the same length.
If the upper left corner is at position, let's say A, right? Then where is lower left corner?
It's the opposite side.
Okay. Or you're not listening to what I'm saying. The upper left corner.
Yeah.
Is at coordinate A.
Okay.
Where is the lower left
corner? What? Wait. If upper left is A, then lower right is.
Lower left. I did not say lower left.
Oh, lower left. It'd be A plus the height.
Okay. Let's just.
Wait. What is A? What is A first of all? Oh, then yeah, it's the same.
You're good. Because if it's the same, then even though they just define the upper left corner, they also define every single starting location, right? It's the same number.
Yeah, that makes sense.
Right?
Mm-hmm.
So that's why you can use y1 throughout.
Okay.
And then you can do the same argument for y2, right? It's the lower right corner, but it's also the upper right corner. So every single thing on the right side uses y2.
Yes. Okay, that makes sense.
Right? So for every row that you deal with, it's always y1 comma y2.
Mm-hmm. Yeah. Okay.
So you just have to loop through starting with x1.
And then end at
And
x2.
for everything in between x1 and x2, including x2.
Yeah.
You have to basically do a full of one lookup in your sums table and subtraction of it, and then
add them all together. Yeah, that makes sense.
Right. That's it. That's the whole algorithm. So
Mm-hmm. Yeah. So I think in a knit is where you want to build the sums.
Right.
So first off, okay, so so rows equals len matrix calls equals len matrix 0.
I'll just keep going, man. I need to pass out maybe in a minute.
Yeah, well, I should be almost done, right?
Let's see. I have wonky coding or something.
Yeah, but wonky.
Okay. You should take this opportunity to become to be deliberate about how organized you are. Right?
Mm-hmm. Okay, so I want to build this answer array. So running total equals new list of the list. Do I even need to say list? I can just do this, right?
So there's two real ways to do this. Right?
I could just
to build each row independently, or you can initialize it all with zeros and then go.
Yeah, I was gonna do that, or I was just gonna. You can just copy matrix, because it's already pre-allocated the space, and you just replace them anyway.
Yeah, you could do that. You could do that.
But then if I do this, if I set equal to matrix and I mess with running totals, does matrix get updated too?
Yes.
Yes, I can't. Yes, I can't do that.
Well, I mean, why not? Like you don't need matrix updating.
That's true.
But I don't know if the interviewer will let you do it. I mean, it's fine.
That's true. Okay. I just pre-allocate with zeros then. I think it was 0 and then that. Was it that?
Be careful. What's on the inner loop and what's on the outer loop?
Oh no, yeah. You want columns inside this. You want rows
right,
outside.
And you also have to range.
Oh, you do.
Right, because you can't have something in a number.
That makes sense. Let me see if that is.
And don't the times should not be there. Might be.
Oh, you don't need that. Okay.
Well, it's not that you don't need that. It's not valid.
Okay. Alright, that looks correct. Okay. So I'm going to loop through this and build the running totals, which should be relatively simple. Okay, so running totals.
And also, well, if you want it to be accessible later on, you should probably self it.
I thought you can call self on this anyway without selfing it. I thought that works. But
well, when you go to some region, I will know what to go.
No, because I remember Oh, I think I defined it out here. That's why it was accessible. If it's in a init, it's not gonna be accessible. Okay, that makes sense. Okay, running totals of row call is equal to matrix row call plus matrix row minus 1 call. Wait, no, it's no, it's just row and column minus 1. Yeah, but then it might be out of bounds, so I have to do range from 1 to calls.
It's not matrix anymore, right? It's a running total, so you should use it self.
Yeah, but I need the starting numbers. Wait, what do you mean? You can't use it self. Oh no, I get what you mean. Okay.
What is this line doing?
No,
It's giving you pairwise.
Okay, wait, no. So you want to sum the previous running total columns with the current matrix.
Yes.
Yeah. Totals row call minus 1 plus matrix row call. But the problem is this will be out of bounds in the first run.
Right, I mean you can initialize with matrix of 0 for this.
Well, I have to do that for every row though.
That's right.
Oh, so like here.
I mean, you do for calling call, and then do an if. If call is 0, then it's just matrix.
Yeah, yeah, that's cleaner. Okay. Okay, else you add from the previous, and then that should be getting you the correct totals. Yeah, because in row will increment each time, column.
Actually, what you could do is have running totals be the thing with actually no, I feel like it's too complicated. No, never mind.
Okay, let me just print this out.
I feel like you get lost in the index, but it will work. The idea was to start with 0 and then just add everything in matrix, right? So then the length of running totals will be 1 longer than.
Oh, okay.
And when you get out of bounds on the left side, it's still 0, so that's fine.
I see. So you just, oh, okay. Yeah, you make a longer array and then you ignore the first the zero
Right,
index.
and then you don't have as many definitions.
That's true.
You can do it. I mean, it's fine. It's the same thing. And then you don't have to do this weird stuff.
I mean, it's not that big of a deal if I have this. It's, yeah, that's fine, I think. This looks correct though.
Okay.
Yes.
So now let's do some reaching, which is the
Yeah. So okay. So. Okay. Now that I have this, okay. So my row 1 is my x1. Wait, why did I delete all my comments now?
you don't have to relabel it. You can just use the code.
No, I'm not relabeling. I'm just saying what it is. Okay. So.
How can you undelete the
So I can have reference. Okay, so for I in range of row 1, row 2. Okay, so if row 1 is
careful. The top of the range is returning.
who at the top of the range?
If you're in range A, B, it will never reach B.
Oh, I set the +1. Okay. And then you want, so now you're looping through these, and then, okay, so you want a sum first, sum equals 0, and then, okay, so I'm looping through these, I want the matrix, so it'll be like a row equals matrix of row of I, and then I want to do the operations on this row. So it would be sum plus equals row of y, no, it would be, it's column 2 minus row of column 1 minus 1. Yeah, because column 2 is the ending index, and this is the starting index minus 1, unless it's 0. So if col 1 equals 0, sum plus equals row column 2, else do this. And then just return sum. define. Oh, what the hell? Matrix is not defined. Wait, why do I have matrix? This should be running code. Oops. Okay, that should be fine. That looks good. Looks good. Oh, they only gave one example. Alright, let's just append some random crap.
Out of bounds.
Is that out of bounds?
Oh, so what you're adding to is the row 1, column 1 stuff.
Oh, right. I need it. Just add.
Create index number 6 and 5 by something.
Wait a minute. How does this input work? So some region.
Here's the upper left corner, lower right corner.
No. Okay. So it's wait. Some region of 2143. What the hell is this? 2143. Return 8. Sum of the red rectangle. Alright, so basically, 2143 is the row 1, column 1, row 2, column 2, right? So I just modify it. So I just mess with this one. No, so, okay. Oh, I see. Okay, so if I want to sum a different one, I have to pass it in. Okay.
Give it different.
Yeah, okay, so.
1, 5, 0, 0.
Yeah, let's do the whole thing. Yeah. Yeah, just do the whole thing. Why not? 0, 1, 2, 3, 4. So it's 4, 4. So let's pass in another sum region, right? Okay, let's see what that one is. Oh, looks good. I think we're good then. Alright, cool.
Right. So I think you should maybe talk through your thoughts a little more, and in general, I still feel like organization is a little like I mean, you catch yourself, which is good, but sometimes they might dock you for if they have to point out that you're missing something. So like the easier it is for you to be like, okay, these are my variables, this is what I'm doing, but like the more clear it is, the easier it will be to code, and the I guess less likely it will be to run into like an easy bug like that.
Okay.
Yeah, nice.
Alright, thanks.